Hello, we're going to be working on problem number 8 of the Siegel book on page 205, and it continues on to 206. So this one looks a little bit more complicated than it actually really is, and it can be solved without using much calculations at all. So here's the beginning of the problem. It says hexokinase catalyzes the reaction ATP plus glucose to glucose 6-phosphate and ADP. Delta G prime is negative 4,562. KQ prime is 2.21 times 10 to the third. And they want you to calculate concentrations of glucose 6-phosphate required to force the hexokinase reaction backwards in the direction of glucose and ATP formation. In the presence of 10 to the negative 5th glucose, 10 to the negative 3rd ATP, and 10 to the negative 4th ADP. Okay, so the setup of this reaction is fairly simple. We're going to be utilizing two equations here. We'll be utilizing our equation delta G equals delta G prime plus RT ln of this, and what our delta G prime actually equals. So you can do this two ways. You can actually plug in the numbers of delta G prime and try and figure it out that way. What I figured out is that it's actually easier to do algebra. So first let's write out our two equations. We're going to have delta G prime, or delta G, equals this is another way of saying the KEQ. Okay, so this is kind of how I did this. Is in order to make this go in the reverse reaction, so we're going to have glue plus ATP G6P for glucose 6-phosphate plus ADP. Okay, so basically to make this go in the reverse reaction from this reaction's making it go negative. So to make it go this way, we need to make this our delta G positive. But the actual point at which it switches from negative to positive is 0. And so that's what we're going to have to calculate for, is when our delta G is actually 0. Because that's going to be the point at which glucose, the concentration of glucose 6-phosphate, is going to force this backwards. Okay, so let's rewrite our equation now. So now we have 0 equals delta G prime, sorry, that's a delta, plus RT ln, let's just write our KEQ. Okay. So after doing some algebra, I'm going to write negative delta G prime. But really, I want to multiply this. Actually, what I'm going to do to make this easier in explanation is I'm going to subtract this whole thing from this side of the equation. So now I'm going to get delta G prime equals negative RT ln KEQ. Okay, so this looks a lot like the actual equation, which is delta G prime equals negative RT ln K prime EQ. So what I'm going to do is I'm going to set these equations equal to each other. The reason I'm subtracted this part from this part is so I could get delta G all by itself, so I could do this. So now we can do simple substitution. It's going to be negative RT ln KEQ equals negative RT ln KEQ, and this could be prime. Or you can have whichever one, it doesn't really matter. So now what we can do is we can divide by RT, negative RT, get rid of that, so now we're left with ln KEQ equals ln K prime EQ. And we can do this all without doing any calculations whatsoever. So now we can take the raises to the e power, which is going to get rid of our natural log. We're going to be left with KEQ. It's going to equal our KEQ prime. Now we're going to plug in some numbers. So as up here, or as in a problem, which I didn't write down, this should be something that you always write down first, so I apologize. This could be A dp is equal 10 to the negative fourth. Our ATP is going to equal, and our glute is going to equal something, and our KEQ is going to equal 2.21 times 10 to the third. So when I actually first did this, I wrote it down the first time, which is what I should be doing every time. So sorry about not doing this in the very beginning. This is going to be 10 to the negative third. This will be 10 to the negative fifth. Okay, so now all we have to do is kind of plug this in. So our KQ is going to equal this right here, products over reactants. So that's going to be 10 to the negative fourth. I'm just going to write x here for, this is really G6P. Which is what we're solving for, divided by 10 to the negative third times 10 to the negative fifth. So now plugging this into our actual equation, this is going to equal the KQ prime up here. KQ prime equals this. So we're going to get 2.21 times 10, to the third power. Okay. So all you're going to have to do is take this, multiply it by this, and then divide by this 10 to the negative fourth. And eventually, after you do all your calculations, which is G6P, which is what they're asking for, the concentration is going to have to be 0.221 molar, which is going to be, you have to very, very high concentration of this in our human body. So you're probably never going to reach this. So in actuality, when we actually have this happen in the human body, you do need some other assistance to get around going in the backwards reaction, but that will probably be later in other classes. Just kind of a side note right now. Okay, hope this helped.